One more, example 5. This one is important. This one is just like your project, so you need to pay close attention to this one. Project 4 is based a lot on this one. Suppose your pet dog weighed 5.5 pounds at birth and weighed 20 pounds a year later. Based on these two data points, find the linear function that describes how weight varies with age. Use this function to predict your dog's weight at 5 and 10 years of age. Comment on the validity of the model. So suppose your dog weighed 5.5 pounds at birth and weighed 20 pounds a year later. They want us to describe how weight varies with age. If weight varies with age, that means weight is our y and age is our x. So when we go to do our data points, we have our x first, which is our age. Our age of our dog at birth is how old? That's right, 0, but he weighed 5.5 pounds. And 1 year later is going to be age of 1 year and weighed 20 pounds later. So these are our two data points. This is our x and our y, and our x and our y. So this is our x1 and y1, x2 and y2. And we get to use the formula that was mentioned before, which was y2 minus y1 over x2 minus x1 equals, to get our m. So in this case, we have our y2 is 20 minus our y1 is 5.5 over our x2 is 1 minus our x1 is 0. That gives us 14.5 over 1, which is just 14.5 for our slope. So our m equals 14.5. Part of it's down. We also need to find our b, which is our starting point, or our initial y. In other words, our y1. So that's 5.5. So now that we have our y1 and our m, we can write y equals mx plus b and get that y equals mx plus b is going to be y equals 14.5 x plus 5.5. It says, this is our equation. It says the equation used to model this situation is blank, where W is the weight of the dog in pounds and T is the time in years. What do you think our X is? We said X was age. Age in this case is going to be what? And W is obviously the weight. That's what we said it was. So weight is our Y. So W equals 14.5. And instead of X, we write T plus 5.5. Okay? That part's done. According to this model, the weight of the dog after 5 years will be blank pounds. 5 years means we put a 5 in place of the T, so W equals 14.5 after 5 years plus 5.5. W equals 72.5 plus 5.5. W equals 78. 78 pounds after 5 years. Check them. According to this model, the weight of the dog after 10 years will be, okay, W equals 14.5, we'll do it for 10 years, plus 5.5. See, not hard to do once we get the function. Just getting the function in there. So W equals 145 plus 5.5. W equals 150.5. Okay. That dog ballooned up, didn't he? Which statement best describes the validity of this model? My dog ballooned up. The model is only accurate for large ages because when the dog is young, it grows faster than when it's older. Well, a dog does grow faster when it's younger, but I don't... Does it keep growing that old? I don't think... The model is never accurate because the dog's weight and age are not related. I don't know that that's accurate. They're a little related. The model is only accurate for small ages because the dog will eventually stop growing. I like that one. That one's pretty good. The model is always accurate because the dog will continue to grow as it gets older. I like C. I like C. I like C. C is much more accurate, much more on point. I like C. You will have a problem like this. You will have one where it affects you. It distinctly affects you. You will need to do. You will have to wait until almost the very end of the class before you get to it, because we have to make sure you've done all of Module 4 before you get to it. However, you will have it. It will be there for you. It will be your Project 4. But it is about this. Make sure you like dog-ear this page so that you can kind of understand it better. Okay. Thus endeth 9b.